Let's work on another example. Let function y of x be implicitly defined by x cubed y cubed minus 4xy plus y equals x equation. And we'd like to find dy over dx in terms of x and y. We're going to solve this problem using implicit differentiation. So we start by taking the derivative of both sides of the equation. d over dx of the left hand side is equal to d over dx of the right hand side. Now we can see that on the left hand side we're going to use the rule for the derivative of the difference of the sum to split all of that into sum of the difference of three terms. Derivative of x on the right is always 1. Then we notice that the first two derivatives are going to be done by the product rule, because there is multiplication between x cubed and y cubed in the first term, and there is a multiplication between functions for x and y in the second term. Now, if we spell out the first product rule, we're going to have derivative of x cubed times y cubed plus x cubed times derivative of y cubed. All of that will be minus all the other terms. And for the other terms, we're going to have product rule for the middle term. Since there is minus in front of that middle term, we have to put parentheses, since this minus is going to apply to both of the terms in the product rule. And the product rule for the second term gives us derivative of 4x times y plus 4x times derivative with respect to x of y. The third term is derivative with respect to x of y, and we have still that it is equal to 1. Now this dy over dx, this is going to be replaced with y prime, and the derivative with respect to x of y cubed, that's going to be done by chain rule. So we arrive at 3x squared y cubed plus x cubed, derivative with respect to y of y cubed times dy over dx, minus 4y plus 4x times dy over dx plus y prime equals 1. And then both of those dy over dx will be replaced with y prime. So we get in this longish expression 3x squared y cubed plus x cubed times 3y squared times y prime minus parentheses 4y plus 4x y prime close parentheses plus y prime equals 1. Now that we're done with differentiating the equation, we solve for y prime. So we have a look on this equation that we got, and notice that there are only three terms that have y prime, so move the other two terms on the other side to get 3x cubed y squared times y prime minus 4x y prime plus y prime is equal to 1 minus 3x squared y cubed plus 4y. Then we see that there is y prime in every term, so we factor it out. Y prime times 3x squared y squared minus 4x plus 1 is equal to right hand side, and after that we divide. And we get y prime is equal to 1 minus 3x squared y cubed plus 4y over 3x squared y squared minus 4x plus 1. That's the end of the problem. Let's solve another example. Let y be implicitly defined by x squared plus y squared equals 36. And we need to find second derivative with respect to x of y, and we need to get some expression with x and y. So we will remember from the previous examples that in this problem we got implicit derivative y prime being equal to negative x over y. What do we know? We know that second derivative is the derivative of the first derivative. So d squared y over dx squared, that is going to be derivative with respect to x of y prime, and it is, and its turn should be equal to derivative with respect to x of the right hand side. So we essentially did d over dx of both sides. Now, to arrive at the derivative of negative x over y, we notice that we're going to need to use quotient rule. So I'm going to proceed with the calculation. We have second derivative is derivative of negative xy. We can factor out negative outside of the derivative and then spell out the quotient rule. It's going to be derivative of x times y minus x times derivative of y, all of that divided by y squared. And then we arrive at negative in front of the whole fraction. It's still same term. Then it's 1 times y minus x times y prime. Derivative of y with respect to x is y prime, divided by y squared. Now what we need to do, we don't need to have y prime in this final expression, so we use that previous answer, that y prime is equal to negative x over y, and we're going to put that into this formula that we'll get. So we have y double prime is equal to negative of the fraction y minus x y prime over y squared, and instead of y prime we're going to put negative x over y. So multiplying out the second term in numerator, we get negative times negative, that becomes positive, and then x times x is x squared, and there is y in the denominator. So we're going to multiply the big numerator and big denominator by y, so that this y cancels, and we arrive at negative of y squared plus x squared times y cubed. What we can notice that x squared plus y squared is equal to 36, and we should be able to replace that expression in the almost final answer. So we're going to go ahead and replace y squared plus x squared with 36 and get that the second derivative is equal to negative 36 over y cubed. And that's a remarkably simple answer. Second derivative of y is equal to negative 36 over y cubed.